Alright guys, let's go. Everyone have it. Alright. So let's look at nitrogen, guys. For nitrogen, nitrogen gas is considered kind of inert. Okay, kind of inert on a few reasons. So the first reason is so nitrogen is exists as odorless, colorless gas, exists as a diatomic or two molecule diatomic molecule, and it is an inert gas. Alright guys, nitrogen, electronic configuration, go. Next part is pretty easy. Alright guys, electronic configuration 1s2, 2s2, 2p3, correct? So it needs 3 electrons to achieve the noble gas configuration for neon. Yeah. So guys, nitrogen atom do this by forming a triple covalent bond. Yeah. How to draw a triple covalent bond? Dun, 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 dun. Know how to draw your Lewis diagram, yeah? This is so IGCSE, should be okay. Alright guys, again, this triple covalent bond is very strong. Okay, the triple covalent bond is very strong. Okay, and its bond energy is almost 1,000. Oh my god, it's crazy. Okay, so therefore it's very difficult to break. Yeah. Alright guys, now you guys please tell me why nitrogen is considered inert. Anyone? Why nitrogen is considered inert? Okay, triple bond is very strong. Well done. Strong triple covalent bond has high bond energy. What else? Joe boy. This coming out. Inert. Why? No, not coming out. Okay, second is nitrogen is non-polar. So they are not being they will not get attacked by any nucleophile or electrophile. Okay, but some of you guys might not know what it is. It's okay. Okay, guys, what else? Anyone else? Okay, last, they have high activation energy. Okay, so as long as a reaction is having high activation energy, means it's not easy for the reaction to proceed. Okay, that's it. Please write down. All right, so nitrogen oxide, let's look at nitrogen 1 oxide. Formula for nitrogen 1 oxide is N2O. Huh? Move in front, see in front of me, come. Okay, so ammonium nitrate is heated. This one don't care. Ignore. Because nowadays you don't need the formula no more. Sure, today class until 10:30. Yes, today class until 10:30. You are right. Alright guys, again today class until 10:30. I'll give you guys a break at 9:30. Alright, next, nitrogen 2 oxide. Okay, it's N. Nitrogen 2 oxide is just NO, yeah. Produced when copper metal is treated. No, don't care. Yeah, skip. Okay, next we have nitrogen dioxide, NO2. So guys, for nitrogen dioxide, right, it's highly toxic gas, yeah. Okay, reacts rapidly when nitrogen, oxide is exposed to air. This equation you need to know. So guys, if I take NO and it reacts with oxygen in the air, it's going to turn into NO2, yeah. Balance the equation, 2NO, 2NO2, done. Okay, and guys, for this reaction, right, can happen easily under room condition, yeah. Okay, on one reason, guys, because for the reaction, the EA is very low. So the activation energy for this reaction is pretty low. So which means that it's, okay, this reaction happens quite easily, quite readily, okay? That's it. Oh, Joe boy. All right, guys, next. We have nitrogen dioxide. So for nitrogen dioxide, it tends to dimerize. So if I take two NO2, right, they can combine together to turn into an N2O4. This also you need to know, not important. Next.
What about nitrogen oxide?
Huh?
Nitrogen 1 oxide.
Nitrogen 1 oxide is N2O. Here. Reaction, don't need to know. All right, guys, next, page 3. This chapter is honeymoon, which means I'm going to speed run it. Okay, so guys, now what we have is nitrogen dioxide. So guys, for nitrogen dioxide, right, it's formed when lightning strike, Okay, under lightning, okay, or under car engine, In car engine, nitrogen reacts with oxygen under high temperature, you will get nitrogen, oxides of nitrogen. Okay, and guys, why under lightning? Because lightning provides the activation energy required, okay, for the reaction to occur. Alright, guys, so we have nitrogen gas react with oxygen gas. Under high temperature, turn into nitrogen monoxide. This reaction, it's under high EA. The EA here is very high. So which means, right, this reaction requires a lot of energy, okay, for the reaction to occur. The energy is supplied by either lightning or in car engine under high temperature. Get me? But once NO is formed in the air, once you have NO, right, this NO can easily be oxidized into NO2. This one, right, is low EA. So this happens anywhere. Understand? Okay, so this happens anywhere. Okay, but for the reaction to form nitrogen monoxide, okay, requires high EA, requires lightning or car engine. Okay, but once NO is formed, it happens anywhere to form into NO2. Clear? Alright, guys, what is the downside of having NO2 in the air, right, or in the environment? Is it's gonna turn into acid rain. Okay, guys, I want you guys to balance the equation for me. Okay, I have nitrogen dioxide plus H2O plus oxygen gas is gonna turn into nitric acid, which is formed as acid rain. Go. Okay, once HNO2 is formed, this is your formation of acid rain now. Please balance the equation. Alright, guys, to balance the equation, I need 4NO2, 2H2O, 4HNO3. Done.
What's the 224 one?
Which one?
224. Like there's a 224 equation like before last time.
The 224. Okay, so the 224 is for nitrate. The thermal decomposition of nitrate. That's it. All right, guys. Once done, please write it down, yeah. All right, guys, next. Okay, so nitrogen gets into the soil and eventually get absorbed by whatever, okay, by plants to make protein. Okay, that's it. Now let's move on. Okay, I want you guys to look at page 4. Let's go. All right, guys, for page 4, let's look at ammonia, yeah. So we're gonna do it quite quickly, yeah. So guys, how do you make ammonia? Process? Haber process, right? Formula? N2 plus 3H2 turns into 2NH3, right? That's it. Delta H here is negative, remember that, yeah? And guys, we need a catalyst, which is iron as a catalyst, remember, yeah? Fe catalyst. Done. All right, guys, next. So for nitrogen, right? Remember nitrogen, for ammonia, it's very soluble in water. Okay, it's a Bronsted-Lowry base. So guys, what is a base again? Base is a proton acceptor. Remember that? Yeah, this is a proton acceptor. So which means, kid, if I take a NH3 added together in a H2O, guys, please tell me what it will form. Okay, so the answer is it's going to turn into an NH4 plus proton acceptor and an OH minus. Done. And you see that a basic solution is formed due to OH formation of OH minus. Done. All right, guys, next. Let's look at ammonia. All right, guys, for ammonia, right, what's the shape again? How to draw ammonia? Bond angle? 107 degree, yeah. So, how's the shape? Trigonal? Pyramidal, yeah. Which is 107 degree. What band? How band? I'll ban you. Bro, 3 bonding pair. How to ban? Ban is 2 bonding pair, bro. Hiya. Alright, guys, what about ammonium? I want you guys to look at ammonium. Please draw ammonium, NH4 plus for me. Tell me the shape. Draw it out. Now. Wow, you guys are scary. Impressive, you guys. Okay, guys, shape, please. Okay, and H4 plus tetrahedral. Bond angle 109.5. Can this so chapter 1, right? Okay, so the lone pair of electrons on electrons can also be donated. What can also be donated to a H plus, forming a dative covalent bond. Yeah. So if I take a NH3 plus a H plus, turn into a NH4 plus. There's a dative covalent bond inside your N. Okay, that's it. Page 4 done. Next page. Copy this. Ay. Okay, guys, once done, next page, let's go. Okay, we have ammonium. Okay, so ammonium is NH4 plus. What we use ammonium for, right? Ammonia is okay, most of the ammonia are used as ammonium to turn into a fertilizer, yeah. Okay, so the best fertilizer that we have is ammonium nitrate. On one reason, ammonium nitrate has the highest percentage of nitrogen, yeah. Okay, so this is the best fertilizer, highest percentage of nitrogen by mass. All right, guys, next. Ammonia can be prepared in the lab by treating ammonium salt with a base. So this reaction, we call it as ammonia displacement reaction. All right, guys, for ammonia displacement reaction, NH4 plus NaOH is going to turn into NH3, ammonia, plus sodium chloride, plus H2O. Done. All right, guys, that is the second question for me. Let's go. All right, guys, second question. NH4Cl plus CaOH2 turns into how? Done here. So to balance the equation, I need to put a 2 here. Turns into a 2NH3, correct or not? Then CaCl2. Then 2H2O. Done. Okay, guys, this reaction, okay, you can take ammonia from ammonium salt by adding a stronger base. Okay, so the base added must be stronger than ammonia. I'm adding a stronger base. That's it. Alright, guys, next. When ammonium reacts with a base, it gives off ammonia gas. So ammonia gas is a basic gas, yeah. So which means if we use a red litmus paper to test it, it's gonna turn blue, yeah. Done. Okay, next page. Alright, guys, use about 85% of ammonia produced from Haber process is used to make ammonium nitrate, NH4NO3. Okay, so the major nitrogen-based fertilizer is ammonium nitrate, NH4NO3. Okay, and this is manufactured from ammonia and nitric acid. Okay, so nonsense, skip. So we use it to make explosive. This one is okay, you don't need to know. So nitric acid, right, we also use to make soap, also used to make detergent, okay, also used to make paint, also used to make nylon. Now don't care. This is so old syllabus. Now not really. I don't think they will ask you. I don't think it's any I don't think it's actually important no more. Okay, so skip this. Next page. All right, guys, now let's look at nitrate fertilizer. So, guys, for nitrate fertilizer, right, this one also can skip. I think nah, it's fine. I'm gonna skip this entire thing. You don't need to know it. Like, really legit. I'm just gonna cross it. It's fine. Don't need to know. Okay, because this syllabus, this chapter, a lot of stuff has been removed. All right, guys, now the next part. Yes, this you need to know. This is your new syllabus. Okay, so nitrogen oxides in the atmosphere. So guys, in engine, right, cylinder, so again, right, in car engine, under high temperature and pressure, nitrogen and oxygen in the air is going to react. So high temperature and pressure. Okay, so nitrogen and oxygen is going to react. Okay, so to turn into NO and NO2, yeah. So guys, now once we have NO and NO2, right? Okay, so this NO and also your NO2, nitrogen and nitrogen monoxide and nitrogen dioxide is gonna react with unburnt hydrocarbon. So guys, where do we get this unburnt hydrocarbon from? It's basically from the car, like unburnt fuel. So to form PAN. So guys, this entire line highlighted. This is so important. Put 5 stars here. This always come out in your P1 and also your P2. To form PAN. Guys, you do not need to know what PAN stands for. It's actually a peroxyl acetyl nitrate, but you don't need to know it. It's fine. You can just write it as PAN in exam. Okay, guys, when you release PAN into the environment, or when you release this oxides of nitrogen is going to cause acid rain due to your oxides of nitrogen, then photochemical smoke due to PAN. So PAN is going to cause photochemical smoke, yeah? Acid rain is by oxides of nitrogen. Does PAN has to be fully uppercase? Yes, correct. PAN has to be fully uppercase. Okay, it stands for peroxyl acetyl nitrate, fully uppercase. That's it. What is photochemical smoke? Good. Photochemical smoke can also be understood as haze. Like that. Yeah. Like a haze, but haze is like brown, grayish color. This is like yellow color. It's like a yellow color haze. Okay, that's it. All right, guys. Next, nitrogen oxide. It's formed in high temperature and pressure in the car engine. I want you guys to write down the equation. Nitrogen oxide plus oxygen gas turns into 2NO. This is underwear. So this is high EA, which means this reaction is only happening in car engine. So once you have NO already, NO is going to react with oxygen further to turn into NO2, yeah. So this one, right, low EA happens anywhere. Okay, so which is why formation of nitrogen monoxide is bad for the environment, because once you get nitrogen monoxide, then nitrogen dioxide follows. That's it. Okay, next. Nitrogen oxide will catalyze the oxidation of SO2. So if I take an NO2 and SO2, so it's going to turn into a NO and SO3. Yeah. So guys, why do we call this as a catalysis reaction? Because once an NO is formed, right, the NO can react react with the oxygen in the air to reform an NO2. So guys, you see, right, the cycle is repeated. So once you have NO turn into NO2, NO2 can catalyze another SO2. Get me? Okay, so this reaction is low EA, which means it's very fast. Yeah? Okay, guys, this two reaction, right, is gonna tell you how NO2 acts as a catalyst. Okay, so how NO2 acting as a catalyst for acid rain? Acid, please write down. Okay, once we have that, eventually acid rain is produced when SO3 reacts with water. So guys, once we have SO3, okay, this sulfur trioxide, right, is gonna react with H2O to turn into H2SO4. That's it. And guys, this is your formation of acid rain. Done. All right, guys, next. Can you screw up? Please can. Okay, done. Is it homogeneous catalyst? Yes, it's a homogeneous catalyst. Well done. That's a homogeneous catalyst. All right, guys, finally, to reduce the emission of pollutants, catalytic converter is used here. So we use a catalytic converter to reduce the formation of NOx. Okay, so guys, what we can use the catalytic converter for? So a catalytic converter converts. Hey, converter, what converter? Oh my God. So a catalytic converter consists of either a platinum catalyst or palladium catalyst and rhodium catalyst. Yeah. Okay, oxidize CO and NOx into less harmful gases. So guys, you need to know how to write the equation. It's going to be 2NO plus 2CO turns into nitrogen gas and carbon dioxide. Done. Okay, that's it. Please write down. Once done, next page. Alright, the fun fact is okay. We're not gonna go through it because we need to rush the syllabus a bit. So guys, skip that. I want you guys to look at page 11. Okay, page 11 up. A second, let me edit the note later. Alright guys, now look at page 11. Here we have sulfur dioxide. So guys, for sulfur dioxide, it's SO2 lah. So guys, SO2 is an acidic gas, yeah. Okay, so when you dissolve in H2, it's gonna turn into H2SO3. And guys, where you get your H2, where you get your SO2 from, right? SO2 are formed, okay, naturally in volcano eruption, yeah. Okay, so as react with oxygen gas, turn into sulfur dioxide. That's it. All right, guys, next. So sulfuric acid, how we get sulfuric acid from, guys? The process, we call it as contact process, yeah. So remember, sulfuric acid is formed from contact process, yeah. All right, guys, look at contact process. Come. So what is our contact process, right? It's referring to this equation here. 2SO2 plus O2 turns into what? 2SO3. My delta H here is negative. And the catalyst needed is V2O5. Okay, vanadium pentoxide catalyst. Temperature here is 450 degree. Pressure is 1 to 2 atm. That's it. I know who you are. Alright, guys, next. Let's look at acid rain. Guys, what are the harmful effects of acid rain, right? It's gonna leach off your nutrients from soil. I'm gonna go through it quite fast because all these are not very useful, not very popular in the exam. So attack the cuticle layer. So acid rain acidifies your nearby water body. So make all the animal harder to breathe underwater. So also attack calcium carbonate, corrode any building. Also corroded by acid rain, any metals building, for example, like Eiffel Tower. Okay, so all the, for example, a railway track, okay, can be corroded by acid rain. Okay, so guys, to reduce the effect, what we can do, remove SO2 and their discharge, okay, before they are discharged to the environment, done. Okay, guys, next. It is only dense liquid at room temperature, strong acid, and guys, it's a very good oxidizing agent that you need to know, and it's also a very good bleaching agent. Done. Okay, guys, please write it down. Once done, let's move on, yeah. All right, guys, next. So let's look at your contact process here. I'm going to give you the 4 equations needed for contact process. So first, we have sulfur, burn with oxygen, turns into SO2. This is so IGCSE here. I'm going to speed run it. Okay, then SO2 is further oxidized by V2O5 catalyst. SO2 plus O2 turns into SO3 by your vanadium pentoxide. Okay, so guys, remember, yeah, the equation here is a reversible for step 2. And after that, once you have SO3, I add into a H2SO4 to turn into an oleum. And you flush it with water, it's going to turn into H2SO4. Done. Alright guys, we are done with this chapter. Yay.